Our next topic is all about nodal analysis. So, in nodal analysis, in this method, every junction in the network that represents a connection of three or more branches is regarded as node. Moreover, considering one of the nodes as a reference point or zero potential point, current equations are then written for the remaining junctions, thus a solution is possible with n minus 1 equations where n is the number of nodes. So, what is the meaning of that? So in nodal analysis, it is quite different from the mesh analysis or the other method of solving the circuit. We are just using here a KCL. Most of our equations are using KCL or Kirchhoff's current law. So meaning to say, we are just considering the every currents on the branch and of course the nodes. So in that illustration, in this kind of illustration, we actually noticed here we have three nodes only. This node and this node and those two. Those two nodes at the bottom will be considered as to one node only because they don't have any resistors interconnected between them. So in total, we have three nodes. In nodal analysis, we have to select a zero potential point or a reference node for every nodes that we had in the circuit. So in that case, we select those nodes here as our zero potential point or reference node. When I say zero potential point or reference node, the voltage here or the voltage at this node is equivalent to zero. So now let's start for the solution. If we're going to take KCL at node A, we have positive I1 minus I2 minus I3 is equal to 0. So I1 minus I2 minus I3 is equal to 0. Now, we have to change those current in terms of voltage and resistances. Then we all know from the Kirchhoff's law, I is equal to what? V over R. So I1, we have to trace the direction of I1 from the illustration. Since I1 is come from the zero potential point, so we start at 0 minus positive E1 minus voltage at node A. Tandaan nyo kung ano yung dulo, lagi tayong naka-minus. So, minus VA divided by the resistance across this branch, which is R1. So we have now here, as you can see here, 0 plus E1 minus VA over R1. So now let's proceed to I2 minus, what is I2 from the illustration? I2 is from node A to the ground or to the zero potential node. So we have now VA or voltage A minus 0 divided by R2. So that's it. Then how about That's it. So how about I3? I3 is from node A to node B. So we have now VA minus VB divided by R3. VA minus VB divided by R3 is equal to 0. Then we have to group the similar terms or the like terms. So we have now E1 over R1, this one, then VA over R1, VA over R2, VA over R3, then VB over R3. Negative times negative times negative is equivalent to positive. So factor out VA on this term. So we have now negative VA multiplied by 1 over R1 plus 1 over R2 plus 1 over R3. Then plus VB over R3 is equal to negative E1 over R1. So that is our equation number 1. So anyway, the target here is to find the values of the voltages across the nodes, the VA and the VB. So next, KCL at node B, we have I3 minus I4 plus I5. So in that case, what is I3? I3 is VA minus VB divided by R3. Same as lang din katulad nung kanina. Then, what is I4? I4 now, let's trace I4. So, you have now VB minus 0 divided by R4. So, VB minus 0 divided by R4. Then, what is I5? I5 now, as you can see here, the current is come from the reference node. So, we have now 0 plus E2 minus VB divided by, what is the resistance across this branch? R5. Parang nag-KVL lang din tayo, nag-loop. So, E2 minus VB over R5. Then, group VA and VB. So, ito na po yun. Let's make it short. So, you have now VA over R3 minus VB divided by 1 over R3, 1 over R5 plus 1 over R4 is equal to negative E2 over R5. So, that's it. After you find the values of VA and VB, you can actually find the values of the current easily. Just substitute on the given equations. Diba? I1 is already this one. I2 is equivalent to this one. Then I3 is equivalent to this one. So on and so forth.